All right, let's start talking our way through page 7. So if we added five points to every test score, help me out with what these scores would be across. It would start at, what would the new score be? 65, 70, 70, 80, 80, 82, 82, 83, 84, 85, 85, 85, 85, 86, 87, 92, 95, 98, 102, and 104. Absolutely. Your distribution, your dot plot, let's see if I can get this to move, should look something like this. What happened to all of the dots? They shifted over. What happened to the overall shape of the graph when we shifted over 5 points? Did it change? Or did the distribution stay looking the exact same, just scooted? Looks the exact same. It's still, I would describe this distribution as approximately symmetric. I would describe it as skewed if we didn't have those 3 points over at 60 and 65. But because of those points over at 60 and 65, I would call this approximately symmetric because we got some low ones, we got some high ones, and we are centered right there around 80. So the shape stayed exactly the same. Did anybody notice that these were the same test scores that we used in the activity on Friday? No. Go back and look at Friday. What was the mean for the test scores on Friday? What did you say? Not the check your understanding, the activity itself. My apologies. It was up at the very top of the page. 80 was the mean. And when I'm looking at this graph, the top one, I've got 4 dots right there at 80. Did anybody happen to find the median of this distribution? What was the median of the distribution? Also 80. So our center is at 80, whether we're using the mean or the median. What happened to the center when we added 5 points to everything? Shifted up. By how much? By 5. We added 5 points. My center shifted 5 points. We increased by 5. My old mean was 80. My new mean was 85. What happened to the variability? What are some measures of variability that we have? We've got 3 of them. Range, IQR, and standard deviation. I know the standard deviation for this from the activity on Friday, but I can't easily calculate the standard deviation for this one without putting all the numbers in. I can use my calculator to make it faster, and I'll show you guys how to do that later. But I think if I wanted to compare variability, range might be the easiest one for me to do quickly. What's the range of the original distribution? 39, from 99 to 60 is 39. What's the range of the new distribution? 39. So what happened to our variability? Stayed exactly the same. My old range was 39, my new range was 39. If we went in and we checked Q1 and Q3, we would see that those both shifted by 5, so my IQR would be exactly the same. When we add or subtract a constant amount to every single point in my data distribution, the shape stays the same. The center will move by whatever we're adding or subtracting. If I was taking 10 points away from everybody's score, then my new mean would have been 10 points less. If I'm adding 5 points to everybody's score, then the new mean would be 5 points more. So when we add and subtract, the center will change by whatever we are doing to this distribution. Yes?
So you see variability Right, like how is like what do you do when you see variability?
So variability, we've got 3 different ways that we can talk about it. The range is one way to talk about it. So if they say, describe the variability of this distribution, you can calculate the range. That's usually considered to be the weakest or the poorest way of talking about variability. Then we've got IQR, which is a better measure of variability. It's definitely better when I have skewed data or outliers. IQR is really the ideal measure of variability, how spread out my data is. We're looking at the main clump, the middle group of data, and seeing how spread out are you. Range takes my minimum and my maximum, which if I've got outliers out here, that's going to make it seem really spread out when most of my data might be around here. So that's why we use IQR a lot of times, especially if we have outliers or skews. And then standard deviation is another way to talk about variability, which we calculated by hand on that one homework and in that one assignment. And I will show you guys, we have a way on the calculator, if we put all of our data values in, the calculator will calculate standard deviation for us. It'll also find Q1 and Q3 for us if we do that. So it's got to be one of those 3 things. If you don't have standard deviation, we would use either IQR or range there. And I'm just kind of shortcutting it for today and using range because I just want to see what's happening here. But we would see if we calculated the standard deviation for this group, for the old group, it's 10. For the new group, it actually also comes out to exactly 10 for our standard deviation. The IQR would stay the exact same number here. So when we add or subtract to a data set, the center moves, but my data distribution doesn't get more spread out. It doesn't get closer together. That's what my variability is showing. It didn't get any more spread out. We just took the whole thing and scooted it down this way, right? So just picking it up and moving it. Shape stays the same, variability stays the same, center changes by whatever we're doing, adding or subtracting. All right. Number 2, where I just double everybody's grades. What are those new test scores then? 120, 130, 130, 150, 150, 154, 154, 156, 158, 160, 160, 160, 160, 162, 164, 174, 180, 186, 194, and 198. What did the graph look like? Looked the exact same. This we would describe as an expansion though, because there's something that I notice when I look at that x-axis between these two. What's different about the x-axis? The scale between my numbers. Here, between 2 numbers, I have a distance of 5, right? Down here, I have a distance of 10 between. We're counting by 10s on the bottom one. We're counting by 5s on the top one. Shape stays the same. What happened to the center? It doubled. Old center was 80. New center is now 160. Now this next question, because of the way this graph is drawn, I feel like it's a little bit harder to see. But I want to talk about variability now. Again, variability is how spread out my data is, and because of the scale on the x-axis, they look identical. But do they still have the same range like they did on the last problem? No. Old range is 39, 99 minus 60. What's the range for my new distribution? It doubled. What is twice 39? 78. If I were using the same scale along my x-axis, what I would see happen is my original graph fits into like this much space, and my new graph would be more spread out like this. So we spread out in both directions, and we did shift because we doubled everything, but the overall shape stayed the same, but we got more spread out. This is what happens when we multiply or divide by a constant with our distribution. Shape stays the same. Whatever we're multiplying by, that will affect my center. That will also affect my variability. So my standard deviation, my IQR, my range will all get multiplied or divided. If I was cutting everybody's grades in half, I was putting these test scores in, like, say, out of 50 instead of out of 100, so I cut everybody's scores in half, we would see the center cut in half, so the center would go from 80 to 40. And the variability would also be cut in half, so we'd be at like 19.5. It would get closer together if I cut everybody's grades in half versus doubling them. Before we go and look at the next page, I want to talk for just a second, because what if I was to do both? What if I was going to add 5 points to everybody's grade and double their grade? Which one would apply first, do you think? What would order of operations have me do first? I'd double it first and then add. Order of operations says we do any multiplying or dividing first before we do any adding or subtracting. And that would stay the same here. Follows order of operations. Let's flip over to page 8. Same distribution of scores. My shape is fairly symmetric with a mean of 80 and a standard deviation of 10. Can you guys go ahead and calculate the z-score for me? This is what we practiced doing on Friday. Calculate the z-score. Y'all finished? Awesome, thank you. It's still 5th period. Oh, what class is this? This is statistics. Nope, you can be a junior, but you have to have finished Algebra 1, Algebra 2 geometry before you can take it. What is our z-score? 1.3. We take the value, in this case 93, subtract our mean, and divide by our standard deviation, so we get a positive 1.3. You don't have to put the plus on there. 1.3 is fine. But what does it indicate with it being a positive z-score? Yes. We are 1.3 standard deviations above the mean. So compared to her peers, she did better. Okay. Suppose I wanted to take all of the test scores and convert them into z-scores. I am not going to make you guys do that to all 20 of those test scores. There's 2 mathematical operations that we need to do to convert all of the test scores into a z-score. First, you're going to subtract 80 from each test score. And instead of having you go in there and do that, I want you to tell me how that would affect the shape, what the new mean is going to be, and what the new standard deviation would be. So on the front, when I added 5 to everybody's score, what did it do to the shape? Stayed the same, stayed fairly symmetric. If I subtract 80 from everybody's score, what will it do to the shape? It's going to stay the same. It's still going to be fairly symmetric. The mean of my original distribution was 80. What will the mean of this new distribution be? 0. 80 minus 80, I get 0 for my new mean. What would the new standard deviation be? How did adding 5 points affect my variability? Stayed the same. So what's going to happen when I subtract 80 from everybody's score? What's going to happen to my variability? It's going to stay the same. So what will my standard deviation be? 10. Variability doesn't change when we add or subtract. So again, that's the first step in finding a z-score, right? We take our value, we minus our mean. So we're going to see this whole distribution stay the same shape, but we're scooting everybody down the number line. Standard deviation stays exactly the same. Then we have to divide by our standard deviation, which in this case is 10. So I'm going from this step to this step. How will my shape change from here to here when I divide everything by 10? How will the shape change? Or will the shape change? It's going to stay the same. If you remember on the front, when everybody's scores doubled, the shape stayed the same. When I divide everybody's scores by 10, the shape will stay the same. What's going to happen to the mean? What happened to the mean on the other side when we doubled everybody's scores? They all doubled. Here I'm taking everybody's scores and dividing instead of multiplying. Will that affect the mean? It will affect my mean, except in this case, my mean was 0, right? What happens when I take 0 and I divide it by anything other than another 0? It's going to stay a 0. Technically, did a change happen? Yes, I divided by 10. So technically a change took place, but it resulted in the exact same value. What will happen to my standard deviation? What happened on the other side when we multiplied and doubled everybody's scores? What happened to my measure of variability? It doubled. In this case, I'm dividing everything by 10. Will my standard deviation stay the same? What will it be? It'll be a 1. When we convert any data set to its z-scores, the z-distribution always has a mean of 0, and it always has a standard deviation of 1. So given any distribution of quantitative data, standardizing the distribution, so turning things into their z-scores, will result in a distribution where my shape stays whatever the original shape was. The mean will always be 0. And the standard deviation will always be 1. Again, this is when I standardize things. This is when we change it to the z-scores. When we change every value to the z-score, in a distribution. All right, let's recap. Next page. Two big learning topics for today, two big ideas. When we add or subtract by a constant, we're going to call that constant A for my example over here. Or when I multiply or divide by a constant, I'm going to call that B. So if we add a constant, my shape stays the same. My center goes up by whatever A is. My variability stays the same. When we subtract by a constant value A, shape stays the same. Center goes down by whatever A is. Variability stays the same. When we multiply by a constant B, my shape stays the same. Center gets multiplied by whatever that constant is. And so does my variability. So center and variability both get multiplied. Or when we divide by a value, by some constant, shape stays the same. Center and variability are both divided by whatever that number is. Second big idea was when I standardize a distribution. So z-scores. Shape stays the same. The mean always goes to be a 0. The standard deviation always shifts to be 1. All right. I would like for you guys to try the 3 parts there on the check your understanding. I'm going to give about 5 minutes, and then we will go through that. I'll be kind of wandering around the room during these 5 minutes, so if you get stuck on something or if you're not sure where to go or where to start, just let me know. I'm happy to help. And just like with the other part of the activity, you may work together if you would like to. So when I say I'm going to change it from days to weeks, every single value is going to get changed. So if I want to change it from days to weeks, I have to count the week. That would be adding. I want to change it. So instead of saying I change my sheets every 14 days, I would now say I change my sheets every 2 weeks. Does that make sense? So I'm not increasing the amount of time I'm changing the way I talk. But it's the same meaning, right? 14 days is the same thing as 2 weeks. So 14 days I will times it in 2 weeks. What would I do to my birthday is 14 days? Take 14 and divide by 2, so I get 2 weeks. Or redivide by 2, divide by 7, because they're all Does that make sense? Yeah, like sometimes it takes me a while to walk through, like, okay, my brain knows 14 days is 2 weeks, and what operations am I doing in my head? So I say, no, we're shitty this divide by 7, change our units.
knowing that you divide the mean by 9, and you divide the mean by 7, so you can figure out how to divide the shape by 7. So here you go. Have this data up here. You could do this as a median if you want to, but it's not to have this data right there. Yeah, yes, definitely. No, but I was thinking that you could just say, okay, so I was thinking if they put it by 7, they can change it. I tried anything by 7 So what would the theory be? In this case, let's see, here it says. How would that number be affected when we make this change? What operation? Adding, subtracting.
Okay, it's just not written very clearly.
Got it. I thought I had a question.
Oh, no.
I think I told you. Re-explain what you already know.
At least I'm not right though.
This is true.
So what would happen to the shape if we change from days to weeks? Shape is going to stay the same. If I change from days to weeks, what operation is happening there? Division by 7. Absolutely. From days to weeks, we're going to divide by 7. And my shape is going to stay exactly the same. What's going to happen to the mean? What happens to my mean? Take it and divide it by 7. So it comes out to be about how big? 6.11, 6.107. If you wrote 6.11, that'd be fine. Stick units on there. We just changed units, so it's really important that we make note of that. And then what would the standard deviation be? About 4.99 weeks. Yes. 4.99, 4.998. So close to 5, it's not funny. Weeks. Everybody following how we got that? Taking this information here and rolling into part B, after reading the article, each person agrees to change their sheets 1 week earlier. What would that do to my distribution? What operation would be happening if we want them to change their sheets earlier? Would that be add, subtract, multiply, or divide? Subtract, how much? 1 if we're using this data. If we were using the original data, what would it be? Then it would be -7 because 7 days in a week. But once we've changed it into weeks, we're going to subtract 1 from all the pieces. Would my shape change? No, shape is still going to stay the same. Would the mean change? Yes. What would the new mean be? 5.11, 5.107. Don't forget to put units on there, weeks. If we're having everybody change their sheets a week earlier, would the variability, would the standard deviation be affected by that? Would the distribution become more spread out or closer together? It's going to stay exactly the same. So what would my standard deviation be? Be 4.99 weeks. Why is it the same? Think about what we did on that very first page, on page 7. When we added 5 points to everybody's score, do you remember how that distribution just looked like it got picked up and scooted down, but it didn't get any wider, it didn't get any narrower? That's what's going on here. Whenever we add or subtract things, we're going to just pick up that distribution and either scoot them over to the left if we're subtracting, set it back down, or we'll scoot it over to the right and set it back down. But the minimum and the maximum will stay the same distance apart because you're just picking the whole thing up and moving it. It doesn't get sucked in like this, and it doesn't get spread out like this. That happens when we multiply or divide, but when we add or subtract, we just shift it. Does that help? Okay. What about if we take and standardize everything? We change everything into its z-scores. How would that affect my shape? It stays the same. Is anything affecting my shape? No. And that's actually really important because that's going to allow me to manipulate this data so that I can find out more information, but I haven't changed the overall shape of my data. What will the mean be if we standardize all the scores? 0. What will the standard deviation be if we standardize all the scores? 1. Anytime we standardize, the mean becomes 0, the standard deviation becomes 1. Did you have a question for me? Yep. Anytime we standardize, anytime we take something and we convert it into its z-score, the mean will be 0, the standard deviation will be 1. So far, so good? Awesome. That is everything that we need to cover for today. Your homework, 2.1, is due tomorrow. Now, with what we covered Thursday and Friday, you guys could do the first 4 out of 5 problems. This is what you needed to be able to do that very last problem, number 5. Remember, variability does not change by adding or subtracting. Variability only changes by multiplying or dividing. If we are both adding or subtracting something and multiplying or dividing, we follow order of operations. And that would only affect my mean because adding and subtracting only affects the mean.